Hello everyone, this is Professor Hu. In this lecture, I will introduce some very basic concepts related with programming. This is the first part, computer architecture. This lecture will cover computer architecture, computer science, software development methodology, and programming methodology. The first part is about computer architecture. Computer architecture is a set of rules and methods that describe the functionality, organization, and implementation of computer systems. I will discuss the two most famous ones that lay the foundation of modern computer systems from different perspectives. One Neumann machine is from the perspective of computer hardware construction. Turing Machine is from the perspective of computing mathematical model. In a von Neumann machine architecture, a computer separates the memory unit from the central processing unit, or CPU. The CPU consists of a control unit, or CU, and an arithmetic logic unit, or ALU, and a very small amount of temporary storage called registers. Registers are not shown in the figure. The arrows in the figure indicate data flow directions between the units and devices. Input devices and output devices are separate from the computer. They are integrated to form a computer system. Keyboard, mouse, scanner, camera, and microphone are examples of input devices. Monitor, printer, and speaker are examples of output devices. Von Neumann machine model has some advantages. One, it has simplified design, so it's cheaper and faster. Because it separates CPU and memory, use the same manner to retrieve data and instructions, and using the same manner to retrieve from memory and input-output devices. Two, the whole capacity of memory is available to the programmers. Von Neumann machine model also has some disadvantages. One, its bottleneck. The bottleneck is because of the instructions can only be carried out one at a time sequentially. Two, it does not allow parallel implementation of the program due to sequential instruction processing. Three, it has a risk of when instruction has to be rewritten due to an error in the program. Another model is Turing Machine. Turing Machine is a mathematical model of computation that consists of a tape that is initialized with a string of symbols, such as zeros and one, and a read-write head that moves along the tape. It defines a set of rules or instructions that controls operations on the symbols on the tape to simulate using sequential memory to store data. And it proved properties of computation in general, and in particular on computability of the decision problem. It also proved the existence of fundamental limitations on the power of mechanical computation. This figure shows an example of Turing machine. Turing machine consists of infinite lengths of tape that simulates zero accessible memory. So it holds zeros and ones. Symbol B indicates a blank. It also has a read-write head with the internal state Q1 here that simulates CPU's input and output of data. In this part about computer architecture, I briefly went over two computer models, von Neumann machine for computer hardware construction, and Turing machine, a computing mathematical model. Thanks for watching.